Okay, so here in we are Protrainy, we are planning to launch this course. Its title is Analysis and Design of Bridges using SAP2000. And this is a demo session for this particular course. What exactly we are going to cover under this course is everything about bridge, its brief history, of course, and its components. Then comes its analysis part. Then comes design part, and then we finally we will before the conclusion of this course we will take this manual analysis and design onto a software SAP2000, and we are going to conclude this course with designing analysis and designing of bridge using SAP2000. So this is the brief. Let's start. Please turn off the mic. So first of all, objective and prerequisites. So the main objective for this course is if you are already in workforce, like in initial stage, like for 2 or 3 years, and you are trying to carve out a niche for yourself. So this course will make you enabled to carve that niche out. Another thing is, if you are a fresher and you are about to enter the workforce, so yeah. So if you are a fresher and you are looking for a stream to catch on with, so again, this course will enable you to get into the workforce with something additional in your hand. So the objective of this course is to make you stand out in the crowd of fresher graduating every year, to make a novice aware about the conceptuality of bridge engineering and design, and to train her step by step from analysis to final design of a bridge. So these are the objectives, and prerequisites is the user should be well versed with the methods of structural analysis and in possession of relevant codes. Now I am pressing this particular point again, that you have to be in possession of relevant codes. The codes I am going to give out during the term of this course. You have to get these codes, and you have to have these codes with you while going through these classes. So this is the course content which we are going to cover. For first and second week, there is going to be an introduction.
Course content first and second week, introduction and bridge, external RCC slab bridging and course, working travel. ए बाबा कहाँ से रे? हाँ?
So then in first and second week, we are going to cover introduction, then bridge loading standards. As I'm sure you guys are aware that bridge loading is way different from your normal structural loading, like a building loading or things like that. So there is it's a whole different topic when it comes to bridge loading standards. Then after covering introduction and bridge loading standards, then we can move on to specific types of bridges like RC slab bridge decks, then comes box culvert, then comes pre-stressed concrete bridges in second and third week. After covering these specific types of bridges, we are going to go to, okay, now these RC slab bridge deck or box culvert and pre-stressed concrete bridges, and these bridges are basically, when we are talking about these bridges, we are talking about bridge decks. But below the bridge deck, it's always bridge bearings, piers and abutments, and lastly, bridge foundation. So by third week, we have covered the manual analysis as well as design of a bridge. And in the last week, what we are going to do, we are going to take a specific case from previous 3 weeks, and then we are going to analysis and design that particular case using SAP2000. So now a brief description about what's a bridge and its evolution up to present. So a bridge is an arrangement made to cross an obstacle in the form of a low ground or a stream or a river or any gap without closing the way beneath. So this is just a definition. Now, the history of bridge engineering is closely related to the progress of human civilization, right? And bridge engineering is kind of engineering structure which our civilization has to overcome first. Then comes bridge structures, and bridge spans were and are presented as civilizational and scientific proofs of an era. The oldest bridge still standing is a pedestrian stone slab bridge dating back to at least 2,800 years old. So this is the 2,800 years old bridge is still standing, and this 2,800 years old bridge is, you can say, it's a proof of the engineering prowess of that particular civilization. Now, India was the birthplace of wooden cantilever bridges in the Himalayas. So as you can see in this figure, this is a wooden cantilever bridge, and in the Himalayas. So you can see that this is what you call piers, right? These structures, these stone structures, this structure of stone masonry, it's a pier, and the bridge is coming out of these piers from both of its ends, and then after pier we have this deck which we basically use for transportation. Then Roman world witnessed widespread use of stone arches using massive piers. So as you can see, this is a Roman bridge, still standing somewhere in Europe or somewhere in Roman Empire. So, and this bridge is the deck is standing on, the deck is supported by these massive arches, and these arches are supported over these piers. So this is a Roman bridge. In modern times, the first treatise on bridge engineering was published in 1714 by the French engineer Robert Guite. In 19th century, demand for stronger and bigger bridges over large rivers resulted in the use of cast iron and wrought iron replacing timber and stones. Before 19th century, as it's clear, as it is clear by this statement, bridges are mainly composed of timber, and if it's a more important bridge, then we have to move on to stones. But after the advent of industrialization, and in 19th century with the advent of railroads and everything, what we need is more strong bridges with larger span. So that's why we have to move on to cast iron and wrought iron. Then classification of bridges. Now, categories of bridges. So as per flexibility of superstructure. First one is as per flexibility of superstructure. What is superstructure? This is superstructure, right? Fixed span bridges and movable bridges. So most of the bridges we have come across is fixed span bridges. Movable bridges are more of a, they are more for military purpose. So fixed span bridges and movable bridges. Then comes as per interspan relations, simple bridges, continuous bridges, and cantilever bridges. So this bridge, if we are talking about this bridge, this is kind of a cantilever bridge, right? Because there is no support in between this span. There is a support at the beginning of the bridge and at the end of the bridge. So this is basically, it's a cantilever jutting out of either ends, and it is connected at the center, forming the deck. Then, as per type of superstructure, arch bridge, bowstring girder bridge, rigid frame bridge, and suspension bridge. As per construction material, cement concrete bridge, masonry bridge, then steel bridge and timber bridge. In our course, we are going to mainly we are going to deal with cement concrete bridge. Then, as per the use, now what kind of transportation is taking place over your bridge deck? So, as per the use, it can be road bridge if it is just we are just using it for motor transport. Then railway bridge, as we are all aware that especially in India, we have separate bridges for railways. So railway bridge. Then there are road cum railway bridges as well. And finally, there is pipeline bridge. These kind of bridges, they are mostly used as a wreck for pipelines. These bridges are not for transportation. Then comes as per the span. There is culvert, minor span bridge, major span bridge, and long span bridge. Culvert, minor span, major span, and long span bridge. So what exactly is a culvert? If the span of your bridge is up to 6 meters, then it comes under the category of culvert. What exactly is a culvert? We have to further this particular point in the main course. Then comes minor bridges. If the span is between 6 meters to 30 meters, your bridge can be categorized as a minor bridge. And again, if the span is over 30 meters, now your bridge is under the category of major bridge. So this is the basic categorization of bridges as a culvert, minor bridge, and major bridge. Now, when it comes to bridge design in India, we have to go according to Indian Road Congress, IRC. So as per IRC, road bridges and culverts are classified according to as per IRC, road bridges and culverts are classified according to the loading as class AA, class A, and class B. So what kind of deck you are going to use and you are going to design, it depends upon what kind of load is coming over to your bridge. So we have these three classes: class AA, class A, and class B. As per Indian Railways, after IRC, for when it comes to railways, we have Indian Railways have its separate codes when it comes to deal with bridges. So major bridges, minor bridges, and important bridges. Again, major bridges, when it comes to, as per Indian Railways, is total waterway more than 18 meter, or having in any span or clear waterway of 12 meter or more. So if that is the case, your bridge has to be categorized as a major bridge. For minor bridge, total waterway has to be less than 18 meters, or having any span or clear waterway less than 12 meters. Above 12 meters or 18 meters, it is going to be major, and below 12 meters, less than 12 meters or 18 meters, it is going to be a minor bridge. Then comes important bridges, those bridges having total waterway of 18 meter and more. So as you can see, if your span is going to be more than 18 meter, then the bridge has to be categorized as an important bridge as per Indian Railways. Now, composition of a bridge. What exactly a bridge is made up of when it comes to its engineering, when it comes to its design. So first of all, what we came in contact with is the deck. So this is the deck on which human or animal or motor transport is going to move on. Now, as you can see that this deck, if this deck, you have these parapets for safety, but it's not compulsion, but you can find these parapets when it comes to flyovers or over bridges. So this is the deck and parapet. Then moving downwards, what do we have is, at its end, you will have abutment. At both of its extremities, what do we have is abutment, and the intermediate support is going to be provided by the use of columns. So this deck is resting over these columns, and then these columns are, again, just like any structure, they are resting over foundations. It can be a pile foundation, it can be a Cassian foundation, or it can be a isolated footing as well, depending upon what kind of obstacle we have to cross. So this is what a bridge is composed of. Now again, deck, pier or column, and piles, but there are in between elements as well, like a bearing. It's a very important element on which your deck is going to rest. So there is bearing. Then we have this girder. So there are so many minor components, but you cannot ignore these components as well. They are important, but basically you can say that it is made up of a deck, a column, and a footing. Grouping of bridge components. So foundation components can be piles, again Cassian, it can be isolated footing as well. Then comes structural components on which your deck is standing. So it is piers or columns, abutments, and lastly superstructural components, which is your deck. So that's it for introduction. If you have any question, please go on and ask. Anybody?
गुड इवनिंग सर.
Yeah, good evening.
सर ये सॉफ्टवेयर ऑफ ब्रिज सॉफ्ट.
Hello.
Yeah, please go on. Yeah, please go on. What's your question? Am I audible or not?
Yes, sir. Are
Okay, okay. So please go on with your questions.
Hello.
Yeah.
Yeah, my name is Praveen. Can you tell about your work experience and your background so that we can understand better how you going to deliver this session?
I am a structural engineer, right? I have a master's in structural engineering. I'm a certified. I'm a chartered engineer as well. I have 13 plus years of experience in industry as well as in academics. Right.
Okay. So in this session, we are going to learn complete software analysis or as well as a manual also both, as I understand, manual calculation.
I am definitely going to cover manual analysis, and when it comes to software, we are going to use SAP2000 for this particular coursework, and you are going to get a brief introduction about SAP2000. And then what we are going to do, we are going to use its bridge designing components when it comes to software analysis, right? So yeah, so SAP2000, when it comes to software, I want to request you all that you are already aware about that we are going to use SAP2000. So if possible, and it's a very SAP2000 is a very often used software, right? You can find it and it's very useful as well. So if possible, what I want is that before initiating software analysis and design, if possible, get this software for yourself and start getting acquainted with it before we initiate it on as a course.
Okay. One more thing, in your presentation, I not seen the construction load, because the very critical load for the bridges will be the launcher. That launcher loading pattern calculation will be covered in this session.
What are you talking about? Construction loads?
Construction load, like launching the superstructure load, the piers and the foundation, the critical will be under construction load.
Yeah, so when we are going, the thing is that when it comes to loading, there are two types of loading when we are talking about bridge. So what loading category we have covered in this session is whatever load is coming over due to the occupancy of the bridge, right? Whatever type of vehicle is going to pass on from your bridge deck, so that is the case. But when it comes to its dead load, like if you are talking about the load of a deck coming over to the columns and load of the columns and deck coming over to the foundation, definitely we are going to calculate, we are going to analyze that loads as well.
No. This construction load means like launcher. The launcher, how it's moves launcher, rear leg, front leg, there will be a concentrated load on the piers. That will be a very critical on this piers.
I'm not getting about, listen, I am not getting your point about launcher. What exactly is a launcher?
A launcher, the segment erection, we are going to cover this segmental erection bridge also, no? In this session.
Segmental erection bridge.
Yes.
Segmental erection bridge. What is this? This is not a type of a bridge.
Yeah, pre-tension bridge.
Pre-tension bridge and post tension. Yeah, sure.
Yeah, post tension bridge.
Right.
So there will be like a critical load. The critical load will be due to the launchers. That you are going to cover in the session, how the calculation will be done on this due to launcher load. Those things will be covered or not? Just I'm asking that.
Okay, so what I'm getting by your question is that launcher load is something. If you are talking about segmental erection, so you are saying that there is a pier already casted on the side. Now you have to move the deck over this pier, right? That is what you are
Yes,
doing.
yes, yes.
No, that is not the part of this course. That is not the part of this course.
And one more about this waterway. There is a due to the water flow, there will be a current. That calculation.
We are going to cover that all. No problem there. Waterway,
Okay.
eddies due to the water and water current. It is all included. It is all covered.
Okay, fine, fine.
Sure.
Thank you.
Sir, software like Lusas and Midas is similar to SAP2000 software, or these are the more advanced version of these software?
Okay. Now, no, the thing is, what software you have mentioned, Midas and?
Lusas.
Okay, I was not aware about that another software. I am aware about Midas, but there is no comparison between SAP 2000 or Midas or whatever you have mentioned, because when it comes to software, I am very much comfortable with any of the CSI softwares, right? So I don't have any experience on Midas, so I can't say whether it's better or not. Sorry. Anybody else?
No, sir. Please resume the lecture, sir.
Pardon?
When this session will start? Which date the session will start? This training session?
It's scheduled I guess by 22nd of February, right?
Oh, what is the timing? Time slot?
It is going to be 7 to 8 in the evening.
7 to 8. Okay, fine.
Okay, class, then I guess let's conclude this demo session for now. And I hope to see you all when this session started. When will this session start? Price, and you have to get in touch with Protrainy people about the price and everything, right? So we have Pallavi or someone who is with us here.
Sir, I'm
Yeah.
Pallavi
Yeah.
from Operation Department. Actually, you will get everything on your mail or through WhatsApp group. The operation team will connect you. Don't worry. Price, time, everything about the course will be given to you. So don't worry.
Sure. So if you have any of you have any queries about the content of course, what we are covering or what we are not covering, again, please go on and ask me, or else we have to conclude this demo session.
Sir, can you tell about something SAP, sir? I don't know what is SAP, sir. So
Okay, SAP 2000 is a software by computer CSI Berkeley, right? And it's one of the it's very how to say, it's one of the first structural designing softwares. And SAP 2000 is basically like how to say, it's like a mothership. It's like Stat Pro. You can use this particular software for analysis and mainly for analysis, right? Mainly for analysis of any complicated structure, not just for your regular frame structures. So that is what SAP 2000 is. It has like SAP 2000, it has various modules in which it also covers bridge design as well. Pratyush, okay, let's again go through course content once more. So for first and second week, we are going to go through the introduction. It's but obvious. Then comes bridge loading standards. That is, as I explained it before, that when it comes to bridge loading, it's totally different from our normal structural loading. So it's a separate topic in its own. So we are going to cover bridge loading standard. After now we have the knowledge of how to load our bridge. Then we are going to move on to specific types of bridges. And when I'm talking about specific type of bridges, I'm talking about its bridge decks, right? So first it's going to be reinforced concrete slab bridge decks. Then it's going to be box culvert, pre-stressed concrete bridges. Then in second and third week, now we have to move below the decks. So when we are moving below the decks, there is going to be bridge bearings, its design, its type, its design, piers and abutments, and lastly bridge foundation. And after these after conclusion of these 3 weeks, in the last week we are going to move on onwards to the software part of our course, which we are going to it depends if we are going to take a case from our previous 3 weeks, and we are going to analysis and design that particular bridge on SAP2000 using the software SAP2000. Okay, everybody. I guess that's it for tonight. Let's conclude this lecture, this demo session for now. And I hope we will meet on 22nd of February. Good night.
Good night, sir. Good night, everyone. And dear learners, please don't worry. We have all your contact details, your email ID, and everything. So whatever will be the course price and time and all the details, you will get there on the WhatsApp or through your mail ID. Thank you, people. Thank you for joining. And
हम ज्यादा कल बोलना, अपना कोई हिसाब नहीं बोलना, भैया बोलना है सब।